Hello viewers, welcome back again to God from the Academy. So in today's lecture, let's answer this question that came in Science paper 1, that's physics 2020 ECZ syllabus. So this question came uh, from principle of moments. So the question is saying figure B 3.1 is a diagram of a load being moved using a wheelbarrow. So as you can see here, we have this load, we have this force, okay, which is being moved by a wheelbarrow. So you can see that we have weight here, W, then we have 0.5 meters, this distance, then we have 1.5 and force F, this is a handle. So the first question, they've said the total mass of the wheelbarrow and the load is 80 kg. So the total mass of everything is 80 kg. Then gravitational field strength is 10 newtons per kg. A, calculate the weight of the wheelbarrow and the load. So the weight of the wheelbarrow and the load, it means it is the total weight, because this is the wheelbarrow and this is the load. So the total weight should be the total what? The total load. So for us to find this total load, we need to use the total mass which we've been given. Okay, so for question A, you're going to calculate, because you understand that weight is given by mass times gravity. So this is going to be weight is equal to mg. So our weight is going to be mass. They said the total mass is what? 80 kg, this one here. So 80 kg multiplied by gravitational field strength, which is 10 newtons per kg. You understand that this is going to cancel. So our weight is going to be 80 multiplied by 10. So you have the calculate with physics. So the answer is 800 newtons. So this is the first answer. Then the second, calculate the force F required to lift the wheelbarrow. So the force F required to lift the wheelbarrow, this force. For us to calculate this force, we are going to use principle of moments. And you understand that it states that the sum of the clockwise moment is always equal to the sum of the anti-clockwise moment. That is for a what? For a balanced moment, okay? For equilibrium to occur, the sum of the anti-clockwise should be equal to the sum of the clockwise moment. So in this case, what's going to happen? We're going to, for us to understand it well, firstly you need to identify the pivot. The pivot in this case is always on the tire here at the center. So here, that's where the pivot is, exactly where the tire is in contact with the ground. So whenever you are making any calculations, you always take a reference from the pivot. So this is going to be our pivot. So whenever you see a tire, where the tire is touching the ground, that is always the pivot. Okay, so if this is our pivot, meaning we're going to be taking calculations from this pivot, all the distances will be referred to this. That's very important. So for us to find this force, we're going to use the same principle of moments. So how is it going to apply? Look at the force, it is pointing upwards. So this is going like this. In short, it is going in the anti-clockwise direction, because understand that this is the anti-clockwise. Wow, this weight here, W, the weight of the wheelbarrow, is pointing downwards. When you see it's pointing downwards, in this case, it's going like this. So this is going in the clockwise direction. So we have two directions here. The force F is going in the anti-clockwise, while the weight is going in the clockwise direction, and hence the principle of moments is established here. So what are we going to say? We will start with this clockwise moment, okay, the weight. So you understand that when we are dealing with the principle of moments, we always say force 1 multiplied by distance 1 is equal to force 2 multiplied by distance 2. Distance is represented by x. So force 1, this is the clockwise, and this is the what? The anti-clockwise. So force 1 is the weight that we have, okay, because weight and force, they are the same since both are in newtons. So what was our weight? It was 800. So that's our force 1 multiplied by distance 1. The distance 1 is the distance from the weight to the pivot, okay, to the center. What did I say? We always take reference from here. So this is the distance 1, which is 0.5. Then force 2 is now the what? The force we are calculating, F. So F multiplied by distance 2 now is again the distance from where F is to where? To the pivot. So this is F, right? So the distance from here to the pivot. So you understand that here we have 1.5 and 0.5. So the distance from here to this side is 1.5 plus 0.5, which is 2 meters. So 2. Okay, from here what are we going to say? We'll say over 2 over 2. This 2 will cancel with this so that we remain with F. So our F force is going to be 800 multiplied by 0.5. You just get your calculate, 800. So 800 multiplied by 0.5. It's giving us 400. So here it's going to be 400 divided by 2, these 2. So our force is going to be 400 divided by 2, that's 200. So 200 newtons. So 200 newtons is this force what? Force F. The last question. State whether force F would increase or reduce when the handles of the wheelbarrow are made longer. So if we were to make these handles longer, what will happen to force F? This force, is it going to increase or reduce? So you should just understand the concept that the length of the handles is inversely proportional to the force required to lift that load. Meaning, when the handles increase in length, the force is going to reduce. Okay, that's the relationship. It's always like that. The longer the handles, the less the force. So if we increase the length of the handles, it means the force is going to do what? To reduce. So here for B, this was A1, A2, A2. This was A1. So for B now, we're going to say it's going to do what? To reduce. So the force will here. The force will reduce. So this is the answer for B. So the force will reduce when the handles of the wheelbarrow are made longer. Alright, I hope you've gotten the explanation. Don't forget to subscribe.